Magic squares. In this video, I am going to present magic squares. As an example, let's fill out 5 by 5 squares. However, we have some requirements here. The first requirement is the squares must be filled out with distinct numbers from 1 to 25 because we have 25 squares here. The second requirement is sum of every row. We have several rows here, 5 rows here, and the sum of every column. We have 5 columns here, and both diagonals, left and right diagonals, equal to the same number. In this example, the sum should be 65, as if we add all 25 numbers and then divide it by 5, at that time we get 65. Therefore, sum of every row should be 65, sum of every column should be 65, sum of the diagonal should be 65, sum of the diagonal also should be 65. So all direction should be 65 here. So we call it magic squares. Let's start to fill out the squares by using the 25 distinct numbers from 1 to 25. First, let's consider the first number, 1. We have to put the first number in the middle of the first row. Then, after placement of the first number, 1, we have some rules for the rest of the number. We have 24 number here because we just put it 1 here. We need to find the modulus of the number which is being considered. Namely, the x represents the number being considered. So, x modulo 5, we get the remainder. Based on the remainder value, we are going to decide the position of the number just being considered. The rule 1 is, if the remainder is equal to 1, place the x at the square just beneath the last number. 1 is the last number. For example, if we are considering number 2, at that time we just take the module and then check the remainder. Based on the remainder value, and we put the next number here. If the remainder is not equal to 1, at that time we put x at the top right square of the last number. This is the last number. At that time we put the number here, just being considered. The third rule is, if the x had placed outside the 5 squares, move it to the square in the opposite side. For example, if one value comes here, because this position is outside of these 25 squares, at that time this number, for example, should come here. If a number is already put it here, because this is outside of these 25 squares, the number located here should be moved to here. This is our rule. Now, let's use this rule and fill out the squares. Okay, now it's the 10 to the 2, because 2 mod 5 is 2. Remainder is larger than 1. So, place it to the square at top right of the last number. The last number is 1, so now 2 position it here. But there is one issue. Since the 2 is located on the outside of the 5 squares, we have to move it to the opposite side. We have that rule. So 2 should be come here. Just like this. This is the final position of 2. Now let's consider 3. Based on our rule, 3 modulo 5 is larger than 1. So this is the last number, so 3 should be come to the top right corner. This is the final position of 3. Now let's consider 4. This is the same rule, and it's positioned here, but there is one issue. Since 4 is located on the outside of the 5, 5 square, we have to move it to the opposite side here. Now, let's consider 5. Based on our rule, the position of the 5 is here. Now, it's time to consider 6. Since 6 modulo 5 equal to 1, 6 will be placed just beneath the 5. The 5 is last number, so 6 should become here. Okay, now let's consider 7. Since 7 mod 5 is larger than 1, therefore 7 will be placed to the top right, here, just here. Okay, now let's consider 8. Now let's consider 9. Since 9 mod 5 is larger than 1, therefore 9 should be placed to the top right. This is the position of 9. But there is issue. 9 is outside of these 5, 5 squares. Therefore 9 should be moved to here. Okay, we have experienced all rules. Namely, when a number should be placed to the top right. 2. When a number should be placed to the under number, for example, like this. And when a number should be moved to the opposite side, just like 9, or just like 2, or just like 4. Now, let's put the rest of the number to their appropriate positions based on the rules above. Okay. 10 should be come here, but this is outside and it should be moved to here. 11, 12, 13, 14, and 15. Now let's consider 16. 16 mod 5 is just 1. Therefore, 16 should become here because the 15 is the last number. Therefore, 16 should become here. Okay, 17. 17 is outside of squares. Therefore, 17 should be moved to the opposite side. 18. This is also outside. 18 should be moved to the opposite side here. 19. 20. 21. Because 21 mod 5 is 1. Therefore, the last number is 20, so it comes here. 22, 23, this is outside, therefore 23 should be moved to here. Now 24, the final number is 25. Okay, unfortunately 25 is outside of the squares, therefore 25 should be moved to here. Okay, now we have completed all numbers. All 25 numbers have been placed. Now we need to verify the magic squares property by summing row, column, and diagonals. Namely, no matter which way, the 5 numbers in each row, each column, and the both diagonals of the squares are added, the sum should be always 65. Now let's see it. First, we take the row. In terms of row, these 5 numbers added, and we get 65. Therefore, this magic square in terms of row, it's correct. Now we take the left diagonal. We have 5 number, we added it, we get 65. In terms of left diagonal, our magic square is correct. we take the sum in terms of this right diagonal, and these 5 numbers added, and we get 65. It's correct. Finally, we get one column here. We have 5 number added, and it's equal to 65. And so in terms of column, our magic square is correct. Until now, we have completed our 5 by 5 magic square. Sometimes we need to play with larger magic squares. For example, 7 by 7, 9 by 9, or 21 by 21, for example. In these cases, it is very time consuming, so we should present a Python code to solve any sized magic squares in the following section. In order to save time, I have prepared the function. Therefore, I just copy the function and paste it here. Then I will call the function print result here. First, I import numpy as np, then define the magic square function name, magic square odd, then pass the number n. Actually, the number is the size of the magic square. This should be odd number. I represents the vertical direction, j represents the horizontal direction during the loop. Then I need one array, two-dimensional array, in order to store the magic squares values. From here, we start looping. Loop through all distinct numbers. Then, based on the remainder value, we have decided the position of the number just being considered. So, first we check the module. If the module is just equal to 1, at that time, place the number to the square just beneath the last number. If the module is not equal to 1, we have different rule. If the number is outside of the 25, for example, squares, at that time, move the number to the opposite side. This is representing that action. Then, calculating index j, this is corresponding to place the number to the square at the top right corner, because we are adding 1 here. So every time is increasing 1. In the end of loop, based on these values, we are deciding the position. Okay, finally, then the magic square values. So this is our function. Now let's call the magic square odd function and print result. I also prepared this code in order to save time. So here I am going to use while loop. If the number is odd, it's okay, we just pass it to the function. If it is not odd, at that time, we just show this message, please enter an odd number. We are calling the function here. We have completed our code. This is the function, and the function is going to call here. Let's save it. Our code looks good, so let's call this function. First, we try to pass 3. Going to display 3 by 3 magic square. Here we go. This is 3 by 3 magic square. In the row direction, the sum of the elements equal to 15. In the column direction, also 15. In the diagonal direction, also 15. Okay, now let's enter 5. Okay, this is the 5 by 5 magic square. We have already seen this during this presentation. So this direction should be 65, and this direction also should be 65, and this direction also 65. It looks correct. And now we enter a little bit larger number, for example, 15 by 15. Okay, if we calculate the 15 by 15 magic square but manually, it's take very long time. If we enter 17 by 17, it's also display all results. So the code looks good, and finally I am going to show the whole code again. This is the function, magic square odd function, and we are calling this function here, just here, using the while loop. Thank you for your watching. Please subscribe.